Classification of impressed forces. 39. The vectors representing impressed electric and magnetic force demand consideration as to the different forms they may assume. Their line integrals are impressed voltage and gaussage. Their activities or powers are EJ and HG respectively per unit volume, and in this statement we have a sort of definition of what is to be understood by impressed force. 4. J being the electric current anywhere, if there be an impressed force E acting, the amount EJ of energy per unit volume is communicated to, or taken in by, the electromagnetic system per second. And this should be understood to take place at the spot in question. It must then be either stored on the spot, or wasted on the spot, or be somehow transmitted away to other places, to be there stored or wasted, according to a law which will appear later on. Similarly as regards H and G. But this concerns only the reckoning of impressed force, and is independent of its physical origin, which may be of several kinds. Thus under E, we include voltaic force, thermoelectric force, the force of intrinsic electrization, motional electric force, perhaps due to various secondary causes, especially in connection with strains. And under H, we include the force of intrinsic magnetization, motional magnetic force, perhaps due to secondary causes, voltaic force. 40. Voltaic force has its origin in chemical affinity. This is still a very obscure matter. For a rational theory of chemistry, one of the oldest of the sciences, we may have to wait long, in spite of the activity of chemical research and of the development of the suggestive periodic law. Yet chemistry and electricity are so intimately connected that we cannot understand either without some explanation of the other. Electricity is, in its essentials, a far simpler matter than chemistry. And it is possible that great light may be cast upon chemical problems and molecular physics generally by previous discoveries and speculations in electricity. The very abstract nature of electricity is, in some respects, in its favor. For there is considerable truth in the remark which, if it has not been made before, is now originated that the more abstract a theory is, the more likely it is to be true. For example, it may be that Maxwell's theory of displacement and induction in the ether is far more than a working theory, and is something very near the truth, though we know not what displacement and induction are. But if we try to materialize the theory by inventing a special mechanism, we are almost certain to go wrong, however useful the materialization may be for certain purposes. No one knows what matter is, any more than ether. But we do know that the properties of matter are remarkably complex. It is, therefore, a real advantage to get away from matter when possible, and think of something far more simple and uniform in its properties. We should rather explain matter in terms of ether, than go the other way to work. However this be, we have the fact that definite chemical changes involve definite voltages, and herein lies one of the most important sources of electric current. Furthermore, there is the remarkable connection between the quantity of matter and the time integral of the current, or quantity of electricity produced, involved in the law of electrochemical equivalence, which is one of the most suggestive facts in physics, and must be a necessary part of the theory of the atom which is to come. That the energy of chemical affinity may itself be partly electromagnetic is likely enough. That even conduction may be an electrolytic process is possible, in spite of the sweet simplicity of Ohm's law and that of Joule. For these laws are most probably merely laws of averages. The well-known failure of Ohm's law apparent at any rate when the periodicity of electromagnetic waves in a conductor amounts to billions per second, may perhaps arise from the period being too short to allow of the averages concerned in Ohm's law to be established. If so, this may give a clue to the required modification. Thermoelectric force. 41. Thermoelectric force has its origin in the heat of bodies, manifesting itself at the contact of different substances or between parts of the same substance differing in temperature. Now heat is generally supposed to consist in the energy of agitation of the molecules of bodies, and this is constantly being transferred to the ether in the form of radiant energy. That is electromagnetic vibrations of very great frequency, but in a thoroughly irregular manner. It is this irregularity that is a general characteristic of radiation. Now the result of subjecting conductors to electric force is to dissipate energy, and to heat them. This is, however, an irreversible process. But when contiguous parts of a body are at different temperatures, a differential action on the ether results, whereby a continued effect of a regular type is produced, reversible with the current, and therefore formularizable as due to an intrinsic electric force, the thermoelectric force. At the junction of different materials at the same temperature, it is still the heat that is the source of energy. The theory of thermoelectric force due to Sir W. Thomson, based upon the application of the second law of thermodynamics to the reversible heat effects, has been verified for conductive metallic circuits by the experiments of its author, and those of Professor Tate and others. With some success, the same principle has also been applied by von Helmholtz to voltaic cells, which are thermoelectric as well as voltaic cells. There are wheels within wheels, and Ohm's law is merely the crust of the pie. Intrinsic electrization. 42. Intrinsic electrization is a phenomenon shown by most solid dielectrics under the continued action of electric force. It is the manifestation of a departure from perfect electric elasticity, and is probably due to a molecular rearrangement, resulting in a partial fixation of the electric displacement, whereby it is rendered independent of the external electrizing force. Thus the displacement initially produced by a given voltage slowly increases, and upon the removal of the impressed voltage only the initial displacement will subside, if permitted, immediately. The remainder has become intrinsic, for the time, and may be considered due to an intrinsic electric force E. If I1 be the intensity of intrinsic electrization, and C the permittivity, then I1 equals C times E. I1 is the full displacement the force E can produce elastically, all external reaction being removed by short-circuiting. It is not necessarily the actual displacement. The phenomenon of residual charge soakage absorption are accounted for by this E and its slow variations. Maxwell attempted to give a physical explanation of this phenomenon by supposing the dielectric to be heterogeneously conductive. This is perhaps not the most lucidly successful of Maxwell's speculations. How far electrolysis is concerned in the matter is not thoroughly clear. Intrinsic magnetization. 43. Intrinsic magnetization is, in some respects, a similar phenomenon, due to a passage from the elastic to the intrinsic form of induction externally induced in solid materials. Calling the intensity of intrinsic magnetization I2, we have I2 equals mu times small h, where small h is the equivalent intrinsic magnetic force, and mu the inductivity elastically reckoned. In one important respect, intrinsic induction is a less general phenomenon than intrinsic displacement. There is no magnetic conductivity to produce similar results as regards the magnetic current, as there is electric conductivity as regards the electric current. But if there were, then we could have a magnetic condenser with a magnetically conductive external circuit, and get our residual results to show themselves in it, quite similarly in kind to, though varying in magnitude and permanence from, what we find with an electric condenser. The analog of Maxwell's explanation of absorption would be heterogeneous magnetic conductivity. This is infinitely more speculative than the other, which is sufficiently doubtful. Ewing's recent improvement of Weber's theory of magnetism seems important. But as in static explanations of dynamical phenomena the very vigorous molecular agitations are ignored, it is clear that we have not got to the root of the matter. We want another Newton, the Newton of molecular physics. Facts there are in plenty to work upon, and perhaps another heaven-born genius may come to make their meaning plain. Properties of matter are all very well, but what is matter, and why their properties? This is not a metaphysical inquiry, but concerns the construction of a physical theory. The motional electric and magnetic forces. Definition of a vector product. 44. The motional electric and magnetic forces are the forces induced by the motion of the mediums supporting the fluxes. To express them symbolically, it will save much and repeated circumlocution if we first define the vector product of a pair of vectors. Let A and B be any vectors, and C their vector product. This is denoted by C equals vector product A times B. The prefix V meaning vector, or more particularly here, vector product. The vector C is perpendicular to the plane of the vectors A and B, and its tensor or magnitude equals the product of the tensor of vector A into the tensor of B into the sine of the angle between A and B. Thus, C equals A times B times sine of theta. If the italic letters denote the tensors, and theta is the included angle of the vectors. As regards the positive sense of the vector C, this is reckoned in the same way as before explained with regard to circuitation. Thus, when the tensor C is positive, a positive rotation about C in the plane of A and B will carry A to B. If the time by a watch is 3 o'clock, and the big hand be A and the little hand B, then the vector C is directed through the watch from its face to its back. These vector products are of such frequent occurrence, and their Cartesian representation is so complex, that the above concise way of representing them should be clearly understood. On this understanding, then, we can conveniently say that the motional electric force is the vector product of the velocity and the induction, and that the motional magnetic force is the vector product of the displacement and the velocity. Or, in symbols, according to equation 3, E equals vector product QB. H equals vector product dq, where q is the vector velocity.